This is video 3. This is the free response section of the review for Chapter 1 and 3 test. Here is a question that has been featured on a previous AP exam. Answer the following questions that relate to the analysis of a chemical compound. A compound containing 4 elements, carbon, hydrogen, nitrogen, oxygen, is analyzed. When this many grams of that compound is burned in excess oxygen, this much CO2 is produced. The combustion analysis also showed that the sample contained this much hydrogen. What we're going to do is this is going to be an empirical formula problem. So we have to get the masses of each one of these elements in the compound. The compound is CH&O, and we're going to ask what these numbers are. If it's 1, 2, 3, or 1 and 1 and 5. And to do this, we have to get the mass of each compound and then apply the mass to mole divided by small multiplied to whole, that poem to it. So we're told first about carbon. The way we're going to find carbon is that we're going to burn this in a bunch of oxygen, and then in a bunch of excess oxygen, or we're going to form this much of CO2. So the CO2, this much CO2 contains all our carbon that was in the original compound. So what we are going to do is we're going to pull the CO2 out of here. Now the way to do it is we can get the percent of CO2, of carbon in CO2, and apply that percent to this mass. But a shortcut to it is you take the mass and you multiply it by the ratio of carbon in CO2. So carbon's mass is 12.01 grams. CO2's mass total is 44.01. I'll be doing this a little quick. And essentially this is the ratio of carbon in CO2. So this pulls out the carbon out of the 2.241. And if you do this calculation, go ahead and do it. 2.241 multiplied by 12.01 divided by 44.01, we get ourselves 0.61155 grams of carbon. So this is how much carbon is in there. Double I says when the compound is analyzed for N content only, the mass percent of N is found to be 28.84%. Determine the mass of grams in the original compound. So we're told that 28.84% of this amount is nitrogen. Well, let's just apply 28.84% to this. We'll have to undo the percent, right, and move the decimal place twice left. So in this case, we're going to do 1.2359 grams multiplied by 0.2884, which in this case, if you do this calculation, 1.2359 divided by, multiplied by 0.2884, we should get ourselves 0.3564 grams of nitrogen. Okay? So let's keep going then. Let's put these, we'll have to remember these. Let's put them to the side here. Let's, so we got oxygen to determine, and then we will do the original. So what, or the whole formula. So let me remember what we had just here. So we had this much carbon and this much nitrogen. Let's go ahead and remember those numbers. So we have 0.61155 grams of carbon, and we had 0.3564 grams of nitrogen. What we'll have to do essentially is get the rest of them and then do our apologies for the little extra time here. Okay. So here it says determining the mass in grams of oxygen in the original sample. Now we were told originally, if you go back to the top, that our grams of hydrogen is 0.0648 or 8 grams. So if we add all these up and then subtract from here, we'll get the mass of oxygen, which makes sense. So let's go ahead and do that. If we add all these up, now I've got them a little off kilter, but you are allowed to use the calculator on this section of the AP exam. So go ahead and you can put these into your calculator. 564.0. So in this case, we have 1.03275 grams. Notice I'm not worrying about significant figures for the time being, because at the end I'm going to worry about that. I'm going to take care of significant figures at the very end. So this is the total mass before the oxygen, which means oxygen is this number minus this number. So we'll do 1.2359 grams minus 1.03275. So we got ourselves 0.20315 grams of oxygen. So what you see is we have all four of these amounts now. So we can do the percent to mass, mass to mole. The percent to mass step is taken care of. We don't have to go through that. So let's set these up as masses. Oops. So we have this much carbon. We have this much nitrogen. We've got this much hydrogen and this much oxygen. Make sure you copy all of the numbers perfectly, otherwise a little bit off will throw the whole problem off. So hopefully we got them all the same. Okay, so mass to mole, let's convert each of these into moles. Carbon's mass is 1201 grams in a mole. Nitrogen's mass is 1401 grams in a mole. Hydrogen's mass is 1.01 grams in a mole. And oxygen's mass is 1600 grams in a mole. So for carbon, and go ahead and keep a little more significant figures, 61155 divided by 1201 gets us 0.05092 moles of carbon. For nitrogen, we've got 0.3564 over 1401. In this case, we have 0.02543 or 44, we round it, moles of nitrogen. For hydrogen, we have 0.06416 moles of hydrogen. And finally, for oxygen, we have 0.01267 moles of oxygen. The next step is to divide by small. So if we divide by small, it looks like the smallest one is this one at the bottom here. Oxygen looks to be the smallest. So we'll divide all of them by oxygen. Now oxygen will become 1, 697. Divide each of these by 0.012697, 0.012697, 0.012697. And this hopefully will give us an insight into the compound. So oxygen becomes 1. We have 1 mole of oxygen. If we do carbon, 0.05092, this gives us 4 moles of carbon. This one looks like it's going to be 2.0 moles of nitrogen, and this one looks like it's going to be, let's find out, 0.06416 divided by 0.012697. It's going to be 5 moles of hydrogen. So here is our empirical formula. We got carbon, we got 4 carbons, nitrogen, we got 2 nitrogens, 5 hydrogens, and an oxygen. So this is our empirical formula. So not too bad if you just follow the procedure that we taught you before. The extra kink, the extra step here is that we're giving it to you as a lab type question. So let's take a look at B. B is going to be pretty easy, and or pretty simple in terms of calculations, and we'll just do that. So here it says a different compound which has the empirical formula CH2Br has a molar mass of 188 grams per mole. Determine the molecular formula of the compound. Remember that the molecular formula is a multiple bigger. So this is the most reduced. The empirical is the reduced version of the formula. The molecular is a little bigger. What we can do is we can compare the molecular mass to the empirical mass. So let's go ahead and find out what the molar mass of this guy is. So if we do a carbon, which is 1201, plus 2 hydrogens, which is 101 and 101, and if we do a bromine, which consulting your periodic table is 7990, we'll find out we got a 3 here, a 9 here. How about 13 here, and a 9 here. So we have 93 grams. So we're looking at 93.93 grams for the empirical, and it looks like it is essentially 2 times bigger. So if you can take a look, 188 is 2 times bigger. The way we find the multiple is we do the bigger number, 188, divided by our number, so 93.93, which is roughly 94, which 94 times 2 is 108. So 2 is the multiple, which means our molecular formula is 2 times bigger, or CH2Br times 2, and gives us C2H4Br2. And this is our molecular formula. And the reason it's called the molecular formula is because this is how the molecule actually looks. All right, that will complete for us these review videos. Hopefully they helped.